Assalamualaikum and good day to my panel, Puan Nurbahirah binti Norddin and Encik Adam bin Samsudin. My name is Muhammad Syafiq bin Azli with metric number B0818104459 from BEEI Section 1/1. My bachelor's degree project title is Investigation of Faulty Capacitor in Symmetrical Shunt Capacitor Bank via Unbalance Current, and my supervisor is Encik Cik Wan Muhammad Faizal bin Cik Wan Muhammad Zalani. I will start this presentation now. For introduction, the Shunt Capacitor Bank SCB always situated closer to main substation to compensate for capacitive reactivation of electricity. When a higher power factor is achieved, so the power loss will be minimized. In this modern era with contemporary technology and the rising use of electrical equipment with motor nowadays, the power factor at the transmission side will constantly be in a trailing condition, and this must be corrected to ensure that the electricity utilization efficiency is always close to the ideal power factor. However, the increased use of capacitor bank has resulted in an increase in the number of capacitor bank failure at the transmission side. As a result, observing the current output from the capacitor bank is the quickest and most straightforward means of identifying a failing capacitor bank. So, an innovative approach for identifying the failing phase and section in capacitor bank are presented in this project. The approach used in detecting the faulty shunt capacitor bank is by on the unbalanced current approach. Okay, for this project, there is three main objectives to achieve in this project. First objective is to investigate and analyze capacitor failure in a symmetrical shunt capacitor bank by looking at the pattern or effect of unbalanced current in the shunt capacitor bank at the transmission side. The next objective is to develop a system that can easily detect the source of shunt capacitor bank failure in industry, so the initial protection measure can be done as soon as possible. And lastly, is to evaluate the performance of shunt capacitor bank to improve the power factor at the transmission side. And now, for research methodology, there is 5 main steps that need to be done in order to make sure this project manages to achieve its objective. The first step is to understand the objective and make preparation for the next step. This step will first start with learning the background and the application of capacitor bank at the transmission side, so this report manage and understand the theory of shunt capacitor bank and its function at the transmission side. This also can find and understand the problem that what will occur at capacitor bank when the failure happen that can lead to power factor fluctuation and can use more energy usage. Okay, now for the second step is learn the theory about symmetrical shunt capacitor bank. For the step 2, this will include all the literature review finding that are already done in chapter 2. This chapter will be filled with all the information for the symmetrical shunt capacitor bank and the finding of theory for shunt capacitor bank based on the previous research that are already done. Some of past study also include some similarity for this project, such as calculation method for unbalanced current method and the simulation by using PSCAP to overview the result that are found in the past study. Now for step 3 is about learning how to use software for the simulation. Okay, for this project, we will use PSCAP software to make a SCB circuit and simulate that what will happen when one or more of the capacitor get broken in the shunt capacitor bank. The result of simulation will be observed and discussed in next step. Okay, for step 4 is to apply the circuit design for shunt capacitor bank and then observe the unbalanced current method. This step is to design SCB circuit based on Telok Mas substation at Melaka. This substation has a 3-phase high voltage with 132 kV with 50 Hz frequency. Every capacitor bank will have 18 capacitor in parallel, 3 capacitor in parallel, and then for every set of parallel capacitor will be installed series with 6 capacitor until it will complete the circuit for one capacitor bank, and then this step will be repeated for every phase. Based on figure 2, this show that the picture for the circuit, the picture of circuit design. The last step is conclusion and summary of the project. And now for the last step of this project is to conclude all the activity that already done to complete this project. It will have the result that will be discussed and what the output and gain of knowledge from this project. This part and step are very important step because it will tell if this project success or fail. But I managed to success in this project. In this step, we'll explain what the improvement can be made to improve in the next project. And now, for result and discussion. This part will explain and show 10 simulation of faulty capacitor in shunt capacitor bank circuit in a proper manner to compare the theory with the simulation that will be done in this part and prove all objective and theory for this project. And now, by referring figure 3 in this poster, that the circuit have one faulty capacitor at IA1, one faulty capacitor at IA2, and two faulty capacitor in parallel in IB3. The current difference is equal to negative 36.97 ampere. That means the I difference is equal to negative 36.97 ampere because IA is 16.43 ampere while IB is 53.40 ampere. If we minus that, we will get the I difference. I difference is in negative value, so the faulty capacitor will be at SCB A and SCB B area. And now, from the graph, it shows that IA1, IA2 and IB3 current peak is lower than other peak current. It means that IA1 and IA2 have one faulty capacitor, while IB3 have two broken capacitor at parallel. There is 6 discussion from this project, and the discussion based on the 10 simulation of shunt capacitor bank circuit. Okay, the first discussion is if the current difference is equal to 0, there is no faulty capacitor in SCB circuit. The second discussion is if the current difference is not equal to 0, that means I difference is not equal to 0, it will be indicating that one of the capacitor in the SCB is damaged. Number 3 is current unbalance happen when the current phase is varies in current flow for every phase based on formula I difference equal to IA minus IB. When I difference in positive, there will be a faulty capacitor at SCBA. When I diff in negative, there will be faulty capacitor at SCBB. And now, based on graph, a faulty SCB will have lower current peak than other normal SCB.
This is simulation for symmetrical shunt capacitor bank circuit by using PSCAD software. The circuit based on Teluk Mas substation at Melaka. The symmetrical term mean that this capacitor bank have two identical arrangement of capacitor. The first capacitor bank is SCBA on the left and SCBB on the right. This circuit based on figure 3 on poster that have one faulty capacitor bank at IA1, one faulty capacitor bank at IA2, and lastly two faulty capacitor at IB3. Now I will run the simulation. Okay, now based on the four faulty capacitor bank occur at this circuit, the I difference we get is negative 36.97 ampere. That will mean this shunt capacitor bank have a faulty capacitor. And now based on graph IA, now for the graph, based on IA1 blue line and IA2 the purple line, we can see that the I peak is lesser than the IA3, the normal no fault capacitor bank. So we can see that this happen because faulty capacitor will decrease the current value. The current peak for IA1, IA2 is lesser than IA3. Okay, now for graph IB. Okay, for graph IB, we can see that the IB3, because IB3 have two faulty capacitor, we can see the current peak is lesser than IA1 and IA2, and even when we comparing for IB1 and IB2, we can see that the value is very different. The current peak is much more lesser because that's mean that this circuit have two or more faulty capacitor, and based on this figure 3, there is two faulty capacitor.
And now, Last but not least is for conclusion and reference. The conclusion from this bachelor degree project is this project managed to find a new approach for monitoring a faulty capacitor in a symmetrical shunt capacitor by using unbalanced current for minimizing this issue by monitoring the neutral current output at each phase of the shunt capacitor bank. According to study finding, if the current difference is equal to 0, there is no capacitor problem in the SCB. The finding demonstrates that if the neutral current varies between phase, it will alter the calculation, then resulting in a current difference greater than 0, indicating that one of the capacitor in the shunt capacitor bank is damaged. Because IDIF equal to IA minus IB, so when IDIF is positive, it indicates that the SCBA has one or more broken capacitor bank, and when ID difference is negative, it indicates that the SCBB has one or more damaged capacitor bank. However, there are some issues that must be addressed in subsequent work on this inquiry. These issues are discussed in chapter 4. And now for reference, there are two most used articles as a reference for this bachelor degree project. The first one is from Samineni, Labushani and Pope, entitled Principle of Shunt Capacitor Bank Application and Protection, that get published at 2010. And the second article is from Abedeni Davarpanah, entitled Shunt Capacitor Bank Transient Issue and Analytical Solution by International Journal of Electrical Power and Energy System, that get published on 2022. So this will conclude my bachelor degree project 2 presentation. Now I would like to express my gratitude to all panel and listener for their time and attention as well as their patience. Thank you.